Hello, welcome to another episode of the IT Wildcard. So this is a sort of follow-up to a question from a previous video. Now the video I'm talking about is the one where I was talking about my history of learning programming languages, and the question came up about, I'd mentioned the word porting. So one of my long-term friends of the channel had asked me about the term porting. So I've given it some thought, and once again I'm going to keep this fairly general. I will try and speak to certain specific examples where I've ported, for want of a better word, certain things. Further on down the line, it's definitely what's the word? Something I'm considering at the moment is to pick a program, fairly simple one, and show it how it looks in different languages, but that's a lot more further down the line. And I didn't want that sort of long-term project, if you like, to hold up this episode. So I've just decided in this episode I'm not going to show specific examples of code. What I am going to do is I'm going to actually use Bing as a sort of conversational backwards and forwards setup, so I can talk about certain considerations, very broad general considerations about this whole challenge of taking one idea in one programming language and moving it to another. So I came up with 4 specific instances where I've had to move code across from one language to another, or in one instance, one version to another. There's probably some more I could think of, but and most of these are pretty low key. I mean, this was major here, but the other, I would say, well, that was a proper internal project as well for a company. The other 2 are more for funsies. So we'll go through just in order, and I'll try and give you a little bit of background. So way back in 1980 something, I was working in microbiology, and the firm I worked for had a computer system that did numerical taxonomy. So how can I explain that quickly? So basically what it did is it took results from tests of an unknown bacteria and compared them mathematically with known results. It does it using probability. Now, we had a software team on site that wrote all the code. I think the code was on DEC mini computers. I can't remember which model, but I do know that the programming language that they wrote in was Pascal. Now, the research manager, the R&D manager at the time, was trying to increase, I'm trying to think of another good word for this. Basically what happened was we sold more kits to the rest of the world than we did to the UK. So he thought that one of the stumbling blocks was that buying a DEC mini computer at that point was quite expensive. There was no, when it was first developed, there was no real PC. However, in the meantime, since when the software had been developed and was being sold, IBM had developed the PC. There were Apples out. The Apple II was out, and there were clones out, like the Amstrad. So I'd already been coding in Qbasic stroke QuickBasic, Qbasic, on the Amstrad, on the IBM clone, and what had happened was he wanted to develop a prototype, a program that ran on a PC, that you didn't need a deck to run, because he'd been visiting offices and noticed that by then, and we're again talking about, I suppose, the mid to later 80s, I think, almost into the 90s, everybody, in their office started to have IBM clones to do word processing and various other things. So he thought, well, here's an opportunity. Why don't we try and develop some software to run on a PC? So he approached me and said, could I write some code to basically do the same thing but on a PC to do? And it was just basically stripped down version. So that meant I had to ask the software department. They weren't too keen on this, because it's like, who's this guy? To look at, print out their code, their Pascal code. Maybe knowing me, I did it surreptitiously, I don't know. I remember there being quite a bit of digging heels in at the time. And printing it off and then basically teaching myself enough Pascal to be able to work out what the code was doing, and then port it over to QuickBasic. The only reason why that was the case is we already had a QuickBasic compiler, Qbasic compiler. So it meant that we could easily I could produce executables that would run on a PC without additional software being installed, even though there was already QuickBasic on there. We didn't want them seeing the code, basically. We didn't want, we were going to, maybe give it to people to try out. So, that's my first sort of introduction, I suppose, to moving from one language to another, was going from a program in language that I didn't know anything about to one I did. I find that obviously that way around is slightly easier. We'll come on to the when you should and shouldn't port stuff across really in a moment. But this, it was a prototype. Now, in the end, it died a death because the software department insisted on doing a full, systems analysis. That killed it basically, because they didn't have the time to do that. And I wasn't a qualified systems analyst at that point. Not that I did work as a systems analyst, but I don't know quite how you would define a qualified systems analyst. But anyway, I wasn't a systems analyst at that point. So I didn't take any further. But it's pretty interesting, and if I was trying to pick a way, obviously in a perfect world, what you should do is, if you're porting from one language to another, is you should be competent in both. But for me, in a professional environment, or producing something that was actually going to be used by an end user that wasn't me, that would, and if I had a choice of, I was in a situation where I didn't know one language, I only knew one of the languages. For me, it's always preferable if I'm going from a language that I don't know to one that I do, because the reason behind that is, I'll come on to when we're talking about idioms, stuff like that. Then the next time it came up was when, this was for my own, fun or learning something. I got access to a copy of, I think, Visual Basic 3. And as an experiment, I took the original software I developed here and moved it over to Visual Basic. That was fairly straightforward. This time it was the other way around, and this is the other scenario where I'd use it in where I wasn't necessarily developing for an end user, again, just developing for myself, is to learn a new language. I find it's quite a good way of, as part of learning a new language, is to do it. So do it from a language you know to a language where you don't know, and use that as part of also reading books and various other things, to learn the new language. Now, obviously, I wouldn't recommend, that as a method for producing, for finishing and releasing product. For me, it's just was a stepping stone in learning Visual Basic and getting competent in Visual Basic. And again, a lot of it's tied in with knowing some of the idioms and the correct way of doing code in certain languages, where you really need to have practiced it quite a bit to get up to a certain level of competence where you start to find out about better ways to structure code in a certain language. Another funsy project, I don't know when this was actually, this would have been in the 2010s, I think. So I wrote in Java this music discovery program which interfaced with the Last.fm API. I think I used, what development environment did I use? NetBeans, I think. So I was actually able to do it in a visual environment as well. It did mean that obviously the software, the system I was running it on had to have Java runtime environment installed, or any system I was running it on. Then what happened subsequently when I taught myself Python, as a first attempt at writing something meaty, I tried to port it across to Python, which I did. And then when I was learning Clojure, after I'd worked my way through the Clojure book that I had, I then took some of the code, like a simplified version, and ported it over to Clojure. So again, there it was just really for learning, a device for learning. And then this one, which was where I was working for a evaluated reseller. So this was, well, actually before, so it was between here and here. But I put it at the end because it would probably be the one where the code ended up in, and released out to a user. And so I was working in Concorde XAL, which is a 4GL. It's like it's an accounting system that uses a database backend, not surprisingly. And there was a client we had amongst several clients where basically they were going from an older version to a newer version. And the older version was sufficiently old that it needed some major rewrites. Because how it worked with the value-added reseller I work with is we sold the base system and then we did mods to make it work how the client wanted it. So this client had some older version of the software, which had like loads of mods on it. So what we had to do is take the new version and do the same mods on the new version, but not all of them worked in the same way. Now, obviously, to do this, we had like a specification from the client listing exactly what they wanted, and we had the original code. The other thing, in parallel, they wanted to have it migrated over the back ends to be swapped over to SQL, MS-SQL. Now, that wasn't necessarily something they wanted, but, and I think I covered this in an episode, because of certain size limitations with the database system that was built into the software, the sort of default system, there was size problems with the size of the database. So MS-SQL made that go away at the time. So there was simultaneous migration. And of course, I'll explain what the difference between porting and migration is in a moment as well, because it's pretty important. When you're talking about moving systems over, and I do not enjoy migrations at all, and we'll see why in a moment. So, just to help me bounce ideas off of here and to refresh my memory, because my memory isn't once what it was. I've just asked Bing Chat a series of questions. And so I was curious about, what its thoughts were on porting and migration, because they're two terms often used interchangeably. So porting is a process of adapting software for the purposes of achieving some form of execution in a different computing environment, such as a different CPU, operating system, or third-party library. Migration is a form of porting that involves moving the software to a new platform without the intention of going back. So let's compare and contrast. So when I was developing a numerical taxonomy program, it was already running fine on a Pascal system. And all they wanted was to, feasibility study, whatever you want to call it, to see if it ran on DOS-based system. If that had succeeded going forward, it wouldn't have made the Dells obsolete. So we wouldn't have, been getting clients swapped over. It would have just meant we'd had two different, flavors of the same software, just one that runs on DEC mini computers and one that runs on a Dell PC. Sorry, there was Dell PCs back then, I think, but Amstrad PCs or whatever, anything that ran MS-DOS basically. So it wasn't a question of, okay, there's no going back. With the one I used for Concorde, the example I used for Concorde Excel, once that database had been moved over to the new system and they'd started using it, because they were then making changes to the database in terms of the account system, there was no going back. So that's a migration. And you can understand the problem with that is you've got to be pretty sure that your, whatever you migrated a client over to is working well, because there is no going back. Or if there is, it's extremely painful. And as it says here, migration could also mean switching to another tool, chain, or programming language. So there may be instances where you could conceivably go back, but you've just decided to stop using one system and started using another. And then I also asked it some general approaches to porting over from one programming language to another. So something I forgot about when I was thinking about this in my head is transpilers. So these are tools that convert source code from one language to another. And this is the point here, which I would also say is transpilers may also introduce errors or inefficiencies in the generated code. Because it's difficult. I've seen it do it with... I did use a transpiler once just to experiment. Was it transpiling from? Was it Visual Basic into C? It was around the time when I was playing around with lots of different languages like Basic and C and Fourth and Fifth and SNOBOL. And I did have a crack with a transpiler just to see what it looked like. And I don't know what they're like now. I mean, things have moved on. But it might not handle the differences and nuances between the languages. I mean, interestingly enough, and I'm not going to try it here because it will probably end in tears, but it is possible to present Bing Chat with a piece of code and say, show me how this code might be done in C, or, so it's like take some Python code and say, how might this code look in Rust? And it to basically produce source code in a different language. But I've only seen it being done and used it myself for short pieces of language. And sometimes it gets a bit weird. This is something else I hadn't really thought about and does come up. So sometimes you might be taking code from one platform and moving it to another. So say you've got something that's been written for running on a Unix-based system. Okay, so say you've got some C code that's running on a Unix system. You've written it in you've written in C. you've compiled it with a Unix compiler to run on Unix, you could then conceivably take that source code and recompile it on DOS. So that you can see that's relatively straightforward to port across, where you've got a language that's written in particular programming language, and you're compiling it to just run on different platforms. So you're not really changing programming languages, but you are changing platforms. Now, again, there might be some aspects of it that you've had to modify because I don't know, cosmetically or some other reason, it may behave slightly different on the different platforms. The other thing it mentions here is more about the sort of tools you might want to use. So obviously, if you're moving from one language to another, there's lots of software tools that you could conceivably use to check, identify, fix codes, bugs, as you're moving from one language to another. And of course, most integrated development environments have those sort of tools built in, and you've got things like Copilot and all these other now AI-driven code helpers which can sort of help with that. Another consideration is frameworks and libraries. So, if you're moving from one language to another, you won't necessarily have access to the same frameworks and libraries in the language you're coming from when compared to the one you're going to. So, one example is when I was coding in, say, Python with my API thing, interrogating Last.fm, I will use certain libraries to do that. Those libraries will be fundamentally different, say, if I'm then writing in Clojure. So, that's the other thing. And another problem is, what if you're porting or moving from one language to another, and the language you're going into doesn't have the same depth of libraries or a variety of libraries that you can leverage. So that means, you're going to have to write certain functions from scratch. So you might have a language which has a particular function that interacts with the API in a certain service, and then when you move over to another language, those functions might not exist. There might not be a library for those functions, or it might not be reliable, or who knows. So therefore you may have to basically write your own functions to do that, which is just extra work. And again, another instance where you've got to really understand the language. And this I've mentioned before. In fact, I did a Ask Bing Chat episode about paradigms. So that's the real one of the I would say the big thing really. The sort of paradigms in one language can be completely different from another. And design patterns, idioms. Actually, the episode was on idioms actually. So you can have an instance where you might have a programming language that says that it is working. Say, your original code was in an object-oriented programming language like SmallTalk, and then you move over to something like, I don't know, Clojure, which is functional. So the whole paradigms are completely different. So the code's going to be massively different to look at, to code, everything. And then on top of that, you've got this thing, as I mentioned before, there's idioms, these different sort of shortcuts and just ways of doing certain things in the language, which we'll come on to in a moment. Actually, I've got a question about that. Which, to write efficient code and write code well, you need to understand those, I think. yeah. So, and also something else I don't know how much people think about in this. One of the things that object-oriented programming was supposed to encourage was reusability. I don't know how successful it's been in doing that, to be quite honest. I've not coded in anger in object-oriented programs, so I don't know how much people have been able to leverage in-house libraries and various other things, the reusable components, to help them with multiple projects. But it does mean, of course, when you port over from one language to another, you lose any sort of pre-existing reusable code. You've got to rewrite that. Now you could then, if you've developed new reusable code, you could then reuse it on a later project, but it does mean that that's all, you can't leverage it. So another lens I wanted to look at this through is core features of any programming language, because they do have commonalities, and that's why I think it's really important to study comparative programming languages, because you get to see these broad characteristics that seem to repeat in languages. Now I know you get differences between paradigms, but things like every language has its own syntax. So understanding fundamentally how aspects of the syntax might be different between Python and C will often give you understanding when you move to other languages of things to look out for. So in Python, indentation is a big thing. C, you've got semicolon, these sort of things. What are the line? Are there any endings on the lines? Do they end in a semicolon? Don't they? How is white space used? Along with syntax, you get something called semantics, which is the sort of meaning of the code, what the code actually does. And then you get into areas of, in one language, you might have made a misunderstanding about the semantics of the language, because you're not familiar with the newer language, and you don't understand the actual meaning of the code, even though it looks very similar. What it means, what it does, might behave slightly differently. So syntax, the specific rules of structure, and semantics, what the code does, what it means, are interrelated, and having again an understanding of how that changes from language to language and the sort of things to watch out for is really useful when you get involved with porting stuff across. Data types, type of values that can be stored in a program, number strings, booleans. How is that different in different languages? What sort of data types do you have access to? What's built on those data types? So you might find that you move to a particular language and there doesn't seem to be very good support for, say, text, and you find that text is actually built on the character data type in some way. So then it's a question of, well, how am I going to deal with text? What do I need to do that? Whereas in other languages, there might be a more, featureful set. Certain data types may just be much, much more better. I'm trying to think of the best word here for this, but just the capability, have better capabilities in certain languages. How they're supported. Things like arrays, lists, tuples, dictionaries. How are they done in the different languages, if at all? Have you got to build certain data structures from data types to get certain things working that just worked straight away in another language. Then you've got the area of variables. So obviously variables are a feature across multiple languages. So yeah, things like how a variable is stored in memory addresses, how the scopes handles, how are lifetimes, static or dynamic, all sorts of things to do with the way variables are handled, and the sort of problems you can get in when you're accessing variables in certain ways. Yeah, are there certain things you have to watch out for where it's possible to overwrite sections of memory with certain data types? So these obviously are interrelated here. Operators, how are the operators handled? What are the operators? I mean, there's obviously a core set of operators that tend to come up across multiple programming languages. But this is a problem area, like the comparison operator. How is that different from an assignment operator? And you can get into problems when you accidentally use one rather than the other, both syntactically and semantically. And then you get these other operators, like there's various Boolean operators as well. And how are they represented in different programming languages? Now, like I said, there's a lot of commonality across different languages, but there's always a few corner case things you have to watch out for, a few gotchas. Control statements and other things. Obviously, when you're moving from one language to another, the variety of control structures might be slightly different. You'll notice things like, if, else, those sort of things tend to turn up in lots of different languages. Switch statements, case statements, things like for, whiles, do whiles, breaks, continue, return. Often those concepts are across multiple languages, but there might be additional control structures in other languages which aren't in the language you're coming from, or they might be called something different, basically. So then functions, and that sort of, I suppose, ties in with reusable code. So these are blocks of code that perform specific tasks and can be reused throughout the program. So there may well be, you may have had in the previous language a whole load of reusable functions, which you've now got to effectively rewrite over time, as different tasks come up. And again, just within functions, like how are they handled, how the parameters handled, how are they named, how are they created, where do they exist in the body of the statement, or the body of the code, what values get returned, how are they returned, how can you return them, how can they be recursed, all these other things, and you find some variability between languages. And then you get languages like functional languages where the whole language looks like one big function. And then classes and objects. So particularly in object-oriented programming, there's certain aspects within there where just the way that you lay your code out and the way you might modify variables using methods or assignment operators, where you're using assignment operators in other languages which aren't so object-oriented. There are different ways of doing actions and operations on variables when you move into the world of object-oriented programming. And then you've got things like classes and various other things like that as well. So there's all of that to consider, to put into the mix. And of course that's particularly a problem when you're moving from one paradigm, like a non-object oriented paradigm or basically any paradigm that doesn't use classes and objects into one that does, and the sort of problems there. Now, of course, a lot of these languages are multi-paradigm. A lot of modern languages are multi-paradigm. So it might be the case that just the point at which you started learning programming, you're already fully aware of classes, objects, those sort of things. The other aspect as well is the whole area of the reusability with these types of things. So I suppose the only other thing I did want to add with this is with data types is with data structures as well. Again, some programming languages just have better functions, better libraries that play nice with data structures, and things like data frames and manipulating CSVs and whatever than others. So if it's really quite unpleasant if you're moving from a language which does do that really well to one that doesn't, and you've got to start interacting with things like data files in some really fundamental old school way. It's quite painful to be there. And then finally, I thought it would be interesting to revisit about the idioms and just ask ChatGPT about idioms. So I said to it, there are 5 modern programming languages and some of their idioms that are important when importing code over from the language. So my question actually was, pick 5 modern programming idioms and then describe for each 5 programming idioms, 5 programming idioms that are important when importing code over from another language. Because I was curious, again, when you have idioms and you know them, they're really good ways of flagging up where you may have to slightly restructure or approach code in a slightly different way, syntactically, semantically. So let's just have a look at this. So Rust, what they say, ownership and borrowing. Rust uses system memory and prevent data races. So here again we got stuff that's deals with the whole thing of mutable, immutable, whether variables can be changed in certain ways, what happens when they get changed, understanding how that works. Different languages place different emphasis on the mutability or immutability of variables. And when you're moving from one language to another, which is a bit more, so the language you've come from, which is a bit more fast and loose with mutability, this ability to change a variable that's already been assigned and has a value in it, to languages which are much more stricter about mutability in them. That's all I'm really saying, I suppose. So what else we've got here? Match expressions to perform pattern matching on different types of values. So enums structure. So you sometimes find in certain languages there's certain idioms where that are really helpful, where certain expressions are just made easier to do when you're doing matching. Just use traits to define abstract behavior that types can generate. Traits can have associated types. Generics allow writing code that works in multiple types as long as they satisfy certain traits. I'm not too familiar with this, I'll be honest, so can't really comment on that. Macros, okay. Old as the hills. So it's interesting when you see languages which have the ability to create macros in them. Create custom syntax, reduce boilerplate, and implement domain-specific languages. error handling. Yeah, so who remembers the bad old days when you had to basically write your own routines to do error handling and what was it called, defensive programming? Now there's a lot of stuff in languages where that can be handled for you, but again, how it handles errors can be vastly different. So then it suggests a Kotlin. So I just asked it for 5 modern programming languages. So we're in the Kotlin, we're in the JVM. Actually, that does raise an issue about when you're working in certain languages, at what point do you get certain types of error? So is it likely to come up at compile time or likely to come up at runtime? So again, that's more of like a debugging consideration and when you're working in integrated development environments, but like how does it handle errors during development? Yeah, special types of data class. Again, like which way around, if you're moving from one language to another and the other one had a cool way of dealing with a certain data type and the new one doesn't, and you've got to do some additional coding, that can be pretty irritating. Always nice when it works around the other way, when you move from a language where certain data classes aren't supported very well into one where they're supported real well. Go and analyze adding new, so extension functions. Oh, okay. So, yeah. So, a lot of stuff in languages which speed up the development of new functions. How is that done? Same, I suppose, when you're working in object-oriented programming with classes. How can you sort of modify existing functions and other features in ways that just speed up the whole process? Coroutines. Oh yes, so asynchronous and non-blocking code. Oh yeah. So other things like, can the language you're working in handle multiple threads? So are there speed improvements through multi-threading that can be leveraged in the programming language? So this Swift is for developing iOS, macOS. Don't know much about it. So let's see how this optionals. Types that have an underlying value or no value at all. Okay. So another type, if you like. So again, languages, some languages might have additional types of variables which aren't necessarily supported directly in another language, and so you have to deal with them indirectly. Structs and enums. Okay, so enumerators. Again, this thing of when you're dealing with, I think if you do a lot of data analysis, data manipulation, data munging, you pretty quickly find out which languages are more pleasant to work in than others. And it does explain why Python tends to be the go-to language for data science at the moment. Protocols and extensions, closures, don't know much about this. Self-contained blocks of code that can be passed as arguments, returned from functions. Okay. I should get around to having a look at Swift sometime, actually. We have Go and TypeScript. Oh, slicing through data. Oh, yeah. That's always cool. Like, so when you're dealing with things like data frames in languages and any form of data structures, and you've got to slice data up. It's interesting how different languages handle slicing through the data and what built-in functions they have available. Structs and interfaces. Okay. Blah, blah, blah. Multiple return values and errors. Okay. So that's back to functions again. Yeah, I suppose if any of your programs feature functions, which is extremely likely, it's pretty obvious that early on you need to just know exactly how values that go into the function and values that are returned are handled. And obviously function definition as well. Coroutines and channels. Oh, more thread stuff. Defer, panic and recover. Exceptional situations. Yeah, so again, error trapping, exception tracking. Again, it's one of the great things with working in more modern languages compared to the bad old days, I suppose, is, now there's functions, features, structures, if you like, that are there for you to use, whereas a lot of errors were prevented, I suppose, primarily through defensive programming, although you still use defensive programming and check for values that can cause problems, but it seems to be less painful. TypeScript. Oh yeah, additional static typing. So superset of JavaScript. Compiles to plain JavaScript. Not used it yet. I did. It's decorators. Aren't there decorators in Clojure or F#? I'm trying to remember. Oh look, it didn't finish off there, but I'm not too worried. Definitely getting in here too, even though I've worked in JavaScript, I'm getting into unknown waters here. I don't really want to comment on so much. Again, this refers to types. Yeah, so anyway, I mean, lots to think about when you're porting and the sort of things that would go through my mind. Fortunately, I don't have to do that sort of stuff in anger. It's all, I use porting as challenges. Well, that's where I would commonly use it, or to learn another language, or just to see how flexible a language is. But, obviously, if you are moving from one language to another in an environment where it's for an end user that's not yourself, then obviously having good understanding of the language you're going from and the language you're going to is really important, and the strengths and weaknesses of the paradigms, the structural considerations, and any idioms obviously are of vital importance. And as I've said before, that's why I find studying comparative programming languages so interesting, because it does start to make learning newer languages easier, because you can start to, it makes it easier to spot the commonalities, I think, when you're shifting across. So hopefully that goes some way to answer or expand on the question about porting. Thanks once again for watching. Bye for now, and I will catch you in a future episode.